So this is where I want to scare you to death with what to expect when you run glideinWMS and you actually want to make sure it works as it's supposed to. So again, a reminder what we're talking about. So gliders are just properly configured start this, so based on the integrate, and the front end is the one that drives the submission. So Condor is still the king, and the glideinWMS it's just a small layer on top of it. So most of the monitoring, most of the debugging will be at the Condor level. So when something doesn't work, don't blame us in the glideinWMS, blame Todd, because Condor is what's doing all this stuff. No, not really.
Here, blame me.
Everything we do wrong is Todd's fault. Everything
Exactly.
we do right is our fault. Or vice versa.
That's what Marone says, and you guys say it.
Another thing to remember is that you have many groups, and the master group just spawns them and acts as an aggregator. So, since it's about monitoring, what kind of monitor we have available? Of course, we have Condor monitor. And since Condor is king, this is what you really want to learn and master. Because in the end, it's just a Condor pool, just a dynamic one. Nothing really special about it. It's just a Condor pool. So you can use any Condor monitoring tools that you find, and they will work. You also have some VO front-end monitoring that comes out of the box and provides some basic Condor monitoring, plus the monitoring of its own internal workings. And if everything else fails, you can ask the factory admins where to look at the factory monitoring, but that should be really your last resort when everything else breaks. This should be the order. Condor monitoring, front-end monitoring, gliding monitoring, factory monitoring. So, what can we do with the Condor monitor? Out of the box, you get online Condor tools and log parsing. And there are several other external tools available, and I'm just showing you two. Pointing to two. Condor View and Cycle Server. And your own portal that you have on top of it may have your own monitoring. I know CDF has a great monitoring application on top of their tools. CMS has a so-so monitoring on top of it. Panda is not using glidings, but they have a pilot system that pretty much does something similar and has great monitoring. So it's possible to do a great monitoring on top of it, aggregating once you get up to this. Especially if you're a big VO and you build a lot of infrastructure. The small VO, well, try to look at something like Cycle Server that you can buy.
You just paid for the T-shirt I'm wearing by saying that.
So, how do you monitor the gliders at the start? Well, the gliders will just register with the collector. So use Condor status, which is the Condor command for monitoring what is in the collector. And the typical thing you will do, you either constrain what you're looking at, and this is just an arbitrary expression, pretty much a requirement. Or you just do a minus total to see what's available in total and see, have a quick look. And then you can decide how you want to see it. With no arguments, it provides some basic information about what's used, what's not in use. Minus long, you have the full class add if you want to see what's going on. Minus format, you select just a few attributes. So if you know which attributes you're interested in, definitely go for the minus format much faster. And if you want to do machine parsing, or you are really an XML guru, do a minus XML and you get the details in an XML format. And here is the link to the manual page of Condor status. So here's a few examples. Condor status without anything. Boom. Essentially, node name, operating system architecture, state, activity, what is the load of the system, how much memory, how long is it there, and the total at the bottom. good for a quick look, but apart from that, the total is here, the only interesting part. Here we go a little more fancy, and we actually look for only specific attributes. In this case, we want to see how much time different sites have, and I want to see only the ones that support more than 24 hours. 24 hours. Boom. Here we go. These are all the gliders that talk. Here is pretty much the equivalent with an XML, and this is just the first line. So it's way more verbose, and you will, yeah, it's really for machine parsing, not so much for human consumption. Unless you're really XML guru, maybe there are some another thing that you can do is part the collector logs, and you have to log into the center manager for that. And you will mostly look into there to find any problems. Each leaf in your collector tree will have its own log, so yes, you will have hundreds of them, which will maybe a little bit intimidating. And they rotate, so make sure you look in the .old tool if you're looking for something that is not capping right now. You will mostly get the gliding authentication logs here and a few other logs, but mostly the authentication errors will be here, and network errors, the basic ones. If you want to know more, you will probably need to increase the debug level and go to the control menu to see all the different levels that you can set it. Set it to full debugging, it will just explode. But you may want more than what is the default. Here is just an example of what the logs are. Very tiny example. Gliding tried to connect, actually managed. And we have a new gliding. Something went wrong. While it was reading the file, the socket disappeared out of nowhere pretty much. So these are the problems. This would be a sign that something is wrong somewhere. Here is an example of what looks like when the gliding dies and the SCSD doesn't know it yet. And it actually tries to connect to it. And essentially the CD says, what the heck? I don't know about the gliding. It probably went away. So a couple of examples of what to expect from the collector log. This is a tiny, tiny thing of what you look into it. Once you install, look into the, you will just, I don't want to teach you how to read the logs. You will just need to learn. Maybe go to the content week. They may teach you more. It's all content. That's about the gliding monitoring. Now let's see what you can do for the job part. You have two commands. Control queue tells you all the jobs that are still in the queue, which means either idle or are running or are held. If you want to know what have ran in the past, you have to use control history. But don't expect to get from the beginning of the time. The history logs are kept only for a small amount of time. It's tunable, and you can go there and see how it is tunable, but it's quite finite. It has very similar command type arguments as control status. And if you want to query a remote SCSD, do control Q minus name and the name of the SCSD, and it will actually go from one node to the other. You cannot do the same for the control history. Control history is only available locally. You have to log in to the SCSD machine in order to use control history. A few examples of how control Q looks like. Without any arguments, you get all the jobs, when it was submitted, it actually ran for any amount of time, what the status, idle means waiting, run, if it's running. The relative priority, as described yesterday evening, how much, this is the image size, I think it's megabytes, and this is the command line arguments used to submit it. You also have the job logs, and I really encourage people to use them, learn how to use them, because they are much more efficient than doing Ctrl Q, especially if you want to monitor things continuously. If you just are curious once in a while, yes, Ctrl Q is perfect. If you want to do it every 5 seconds, look at the log files, or you will essentially kill the scheduling. And this is how the logs look like. And by the way, this dot dot dot, it's literal. It's not me putting them up. This is the separator in that Condor uses between events. Similar to the collector, the daemons also write their own logs. You have one log for the schedule, one log for the shadow, so you don't have one particular job, which is good. And again, you have the old files, so anything that is not happening right now, make sure you look in the old file as well. And there is lots of interesting info in them. They have quite high verbosity by default. We have a few examples, yes. Example, schedule log. Here we had a problem. No such job. I think it was Q, other Q. Here we see that the schedule just noticed the job failed. No, actually it succeeded. Status 100 succeeded. Here it's when it ran through a negotiation cycle, so it tells you that it actually went to the negotiation. And what claimed, what actually matched. So this is just, again, tiny little bit of what you can expect in it, but that's huge amount of information. Again, I will not teach you what's inside, but just so you're aware it is there, and you need to learn from someone else how to parse it. This is a shadow log. Essentially says, okay, I'm starting a new job, and you see it, you have, apart from the initial ones, you usually have job ID embedded in it. Yeah, just try to run this job, it actually managed to start running here. Here another job finished. Exit status 100, I'm being told it's a nice one. Here we actually have a problem. When trying to talk to the node, it failed, and the start date was actually good enough to tell us that the disk was full, so gliding with a full disk. This kind of stuff you will get. The shadow exit is something like 100, so that's a bad thing. And I couldn't find a list of all these exit codes, although I remember seeing them at least at one point in time. Now, the schedule also advertises a couple of class ads that are specific, that are not per job, but they are more generic. You have one that just says, I'm here, whenever you want to talk to me, this is my address. These are the schedule daemon class ads. If you do contact status minus schedule, you see all the schedules you have in your pool. And it also sends out the per user class ads, which tells you which users are in the system, how many running idle held jobs they have. And you get this with contact status minus submitter. It can be a very nice way to get summary view of what's going on. Of course, it doesn't tell you which jobs are there. For that, you have contact queue. But it gets you a high-level picture of who's requesting what, and who's requesting how much. So you can get an idea how busy your pool is. And here's an example. This is contact status minus schedule. You have a bunch of schedules, this many running jobs, this many idle jobs, this many held jobs. And here is a detail with minus L, it's minus long of the class add, which is essentially the same thing that gets printed out, plus a bunch of other things. The submitter class add essentially says it per user. User adds what node, how many running, how many idle, how many out. And I don't know really exactly why it repeats it twice. Twice is name machine, the other times is just the name, exactly the same information.
You can have the same submitter at two different schedules.
Ah, okay.
So the bottom is summarizing.
Yeah, because this is the this doesn't need to be per name. If you have the UID domain set equal to different schedules, yeah, the same user can be at different nodes. Okay, I understand. Still a little weird to see nodes. But this is what you get if you run. You can also monitor what the computer is doing, essentially the condor user prior that I showed an hour ago. You use it also for checking what the current priorities are. If you see that a user has a bunch of jobs that are not starting, and he's your boss, and he wants to know why, and you say, oh, you really used a lot yesterday, so everybody else has better priority than you, and he then say, tweak my priority factor, but if you don't, it should be normal, and you say, okay, I'll wait another hour and then do my turn. But this is how you see it, why certain jobs sit in the queue even if they're higher up in the list condor queue than the others. For troubleshooting, you look into the negotiator log. Errors are usually pretty obvious. It says error something. And it may be a problem of talking to the skip deed, or something is wrong. Yeah. And you also have the negotiator class if you want to look at it. Provide some overview. I think I have here. No, this is the output of condor user prior minus all minus users. This is just half bit, it's huge. So username, effective priority, real priority, priority factor. The source is used, it actually tells you how many glidines this user is using at this point in time. How much it has used since the beginning of time. When is the beginning of time for that user, and when it was last seen. So you can actually filter out users that have not been active for years or days or months, whatever you're interested in. An example of negotiation log. What goes? Yeah, it says what it's doing. Here it rejected a job because it found no match. This was the highest priority, but it couldn't match because there was no match. And here it said found one after a while, and you see where it went. So if you want to, if you have many schedules and you want to see what's going on on a global picture, here you see all the matches that are happening. And of course, all the errors. Now, a very short overview of the cycle server. It can do much more than just monitoring, but that's beyond the scope of this talk. It can do monitoring too. And the monitoring has a few nice features. Starting with nice pie charts, some configurable graphs. You can correlate anything with anything. Web 2.0 like, so you can change all things. It's a web portal. You can go into details with the class ads. Here you see the groups, you can change them. So it has a few, well, yeah, just nice pictures. And another nice thing is that it's pretty much free for academic use. So it's a commercial product, but for academic use, they ask for something like a $10 donation, which in my book is free. So you just need to register, and actually the donation is optional. They don't even insist on it.
academic depends on your academic institution, though. I wasn't able to get. There was some limit on, last time I talked to Jason, there was some limit that we didn't have time to negotiate, but I think once we hit, it goes our pool hit 5,000, they were less interested in providing cheap pricing.
We have we have a license for 16,000.
You're at San Diego University, I'm at a national
Yeah.
lab. So.
It depends. They are commercial, so if they think that you have the money, they may ask it.
But I mean, it's fair to say this is a relatively recent change in there.
Yeah.
Over the last 2 years, I think, right?
Yeah. So I'm not selling it. I'm just telling it's there. This is actually from the UCSD monitoring, not of the gliders, but of the regular condor pool. And Terence has been quite satisfied with it. So just so you know, it exists. So this is about condor monitoring with no gliding, glideinWMS front end, anything in it. Now what the front end provides on top of it. So a few things. We provide a helper command line tool that it's similar to condor status, but that's a few more things in a second. Plus, each activity group provides their activity and error logs, so to monitor how the front end itself works. You will have the RD files with all the statistics, XML files with the current snapshot, and resource class adds. On top of that, the master front end will aggregate the various RDs and XML files into something that contains everything together and provides human readable or viewable, if you want, web pages so that you don't need to actually look at the bits and pieces of RD or XML files, although they are there, and this is what is actually used by the web pages, so you can use them. If you want to implement your own monitoring, that's where you probably want to start with. You don't want to parse the web pages. So first about the helper command line tool. It's essentially very similar to condor status. It's called gliding status. But it provides 3 columns on top of it of condor status and 2 less. We have actually advertised architecture and OS because they are usually not interesting in the gliding case. So if you use gliding status, you will get the site, the factory, and the entry that requested that the gliding. So, and it's really long, so it won't fit on the slide. This part is essentially the same as condor status. So that you actually at the site can see where the glide is coming from. And while this is going to be obvious, this variant Padova, actually this is Legnaro, PD. Weird. Ah, I see. It still has PD. Oh, see? I thought this was Padova. It's really Legnaro. Nothing I have gliding status. And it's pretty much the same. It just provides the other fields. And under the hood, it's really condor status minus format, and then format nicely for the users. Now the log files, this is really where you want to see what's going on with the frontend itself, not with the pool. So the info will have the progress and warning messages. So when you want to see what's going on, this is where you start. The error will have just the one-line warnings. So if you want to have the terminal open with tail minus F and just see what's going on, if any new error messages coming in. You want to see the history, it's better, so you see the context. And most warnings will print something in the debug line if they want to report something that is long, multi-line, it will not be here, it will be a different file. And this will likely change with version 3, but this one is now. The master, and this is for the groups. The master frontend has very similar things that you will rarely see any interesting in there. So most of the time, don't even bother looking there unless you exhaust the group ones. And here is an example of what you will see. So essentially, it says, okay, I started my iteration. I'm querying Condor. I'm trying to talk to the rest of the world. Okay, once get this down, fine. This is what I found. This is the number of jobs, number of glidings, how many proxies I'm using. Okay, now I'm matching. I'm starting counting. Takes a while. This is, and here is what I found. So for each iteration, it actually tells you exactly what the matchmaking was, which is pretty verbose. So your log files will be pretty big, and there's no way to tune them down. So,
and this is just info, right?
This is just info. It rotates every day, so if you don't care, just delete them. But they're not that huge for the modern day, and unless you have a small SSD, you should be fine. But yeah, they are not small; they are sizable. And then it tells you that it's talking to the factories and everything went right. As example, error log. I failed to talk to factories. I failed to talk to the SCADs. And if you look in the debug log, you see the details. I tried to run this command, and Condor returned with these error messages. Failed to talk to the SCAD, and the SCAD says, well, this machine doesn't exist. So this is very high level, and this is the details. Sometimes you will just look into this. This is easy to grab, and this is when you want to actually debug by hand.
Can you go back to the default for a second?
Sure. I may have doctored some numbers, but
no, I'm just more interested in what column headers mean.
okay. So this is pretty much what you get on the web pages too. So let's start with match. Match means this many jobs match this specific factory. Out of those, 169 were older than 6 hours. Then we actually calculate, we divide this number by the number of, well, remember when I said we count all the glidings that match, and if a job match more than one factor, we divide by the number of factories. This number is the divided number. So this is how many in absolute jobs, and this is how many effectively are when you count them. So if a job matches 10 sites, we will count 1/10 here and 1 here. Unique means that these are jobs only can run on this side. So if you have this different than 0, you should really care about this specific site because they cannot run anywhere else. Run, this essentially means how many of the matching jobs for this site actually ran and how many actually ran on this site. And this is what is the limit that you have set for this specific per entry limit that you want to have, which is 50. For the gliders, these are how many gliders actually have currently registered, how many of those are running, and how many idle. If this plus this is plus this, it's probably benchmarking or something like that. It's just starting up. Here it's what is being requested to the factory, how many idle, this is the pressure number, and this is the max run. This is the maximum amount you ever want to run. And I think in recent versions of the gliders should be even lower than that. And this essentially tells you if the factory is up or down. If it is down, essentially means it is temporarily disabled for whatever reason, jobs do not start. But we may still want to request in case the factory just decides just to start them in the next round. And these are the names. And these three are just the summaries. This is the sum of all the ups, this is the sum of all the downs. And actually this last one, it's interesting. We'll talk about it in a moment. But this is how many of the jobs don't match any of the factories. So in this case, we say, well, we have 37 jobs that will never run because they don't match any single factory that we know about.
Factory is a little misleading there. It's really entry.
Entry factory, yeah. So factory, I mean the factory class. And I am mixing factory with factory entries, factory collectors.
And the status up and down is managed by the factory?
By the factory, yeah. Usually if the factory is down, it means something is broken.
And so you have disabled?
Yeah, we have temporarily disabled it. Yeah, we expect to enable it anytime now, but it may be down for a few days. Yeah. Maybe the site is in downtime, or we see that all the clients are failing, so we start stopping it until we figure out why and the site fixes it, stuff like that. But it's temporary solution. It should be temporary. If it lasts for too long, you should ask. Did you by any chance forget to bring this entry up? It has happened for a couple of times. So there are the logs. And then you have the web pages, which is probably what you want to look at on a daily basis. This one, frontend status.html, gives you a historical overview of what's going on with your pool. It's fully dynamic, it allows for zooming, changing different things to be seen. It's completely client-side, so it doesn't put any load.
Sorry, may I interrupt you just a second? At 4 o'clock, we're going to have a seminar. When do we finish?
Probably around 5. I had this room reserved for the whole week.
No, this is reserved for seminars that matter physics. So, are you sure?
Yeah, I'm pretty sure that reserved.
7:30?
I'm high energy physics, but I have arranged for the whole week to have it reserved.
Let me check.
Yeah. So yeah, you can see what's going on up to a year with different levels of granularity, and you can see both the global view or per factory or per group. So you can actually navigate through it. You also have the frontend groups status now.html, which has two parts of it. In the bottom, you have a table, which essentially shows you the same thing you have seen in the info log. Not exactly, almost. It's the same things that you see in the historical view, but this is the latest snapshot. And you can sort and see what's going on. So if you drill down into it, you want to see the latest snapshot. This is where you see it. And on top of it, you have nice pie charts. So you see what's the bigger offender and what is peanuts that you don't have to worry about. I'm not going into details. Look into it. It's nice. So the web pages are just renderings of the RD and XML pages. So the raw data is loaded in the browser and then rendered. There is no server-side code. Okay, so don't worry about overloading the factory doing this. And other tools could use this data. They are publicly available by default unless you want to restrict it in any other way. And there is no user-identified data. It's just sites and numbers. So there should be no problems with privacy. Now the frontend also actually front groups advertise one class app per group for each factory that is requesting license from. And the class apps have the type of glider source, so you can actually query them. They are in your VO collector. And they contain pretty much everything the frontend group knows about the factory. Most of the stuff that you have seen in the log and in the web pages gets also reported here, so you can actually look into it. And among other things, the factory activities used for matchmaking, stats about the monitoring job, what is being requested, even what the factory is doing, which currently is not available either in the logs or on the website. It's not a conda native type, so you must use the -any and then do the constraint. So to figure out what's going on, you do conda status -n minus constraint, my type is equal glider source, and then format whatever you want. In this case, I just took all the names, so this is how they are called. And this is even remotely queryable. And here is an example of one class app. And you see you have your own identification, you see what is being used, so essentially how many idle jobs match, how many running jobs you have, what is being requested, a couple of examples of attributes that the factory is advertising. This is what I'm seeing about the glidins. I know that I currently have 215 glidins registered that match this factory, and this is what the factory is think is going on, which is bad because I have way more running than I have glidins running. So But yeah, you get a lot of information if you want. And you can automate if you have any visualization tool that you want to pump it into, just do it. It's there, it's available. Now, we know what's available. Now, what do we do with all this information? Or what to look for? There are six major areas to look after, and your goal is to have few unclaimed glidings, no unmatched jobs, reasonably low restart rates, reasonably low failure rates, negotiation cycle which is reasonably short, and the SCAD node that is not overloaded. And let me go over each of them. So, as I said, the front-end negotiator policies are not identical, so you may end up with glidings that never run any jobs because you just screwed up. The discrepancy can be big enough to be noticed on a global scale, but more often than not, it's just one front-end, one factory or site that it's starting glidings but never matching anything. Short spikes are fine because you might just have a lot of gliding starting in a burst and just need some time for the next ship to catch up. But if it stays high for a long time, that's bad. Here's an example. So here we have, these are just snapshots from the monitoring. And yeah, we have some more shots here and there where we have some unclaimed. Perfectly normal. That's good. That's bad. So if we have consistently.
Sorry, it's been Patty's error, so she's coming up, and I'm sorry, but you will have to move. This is reserved the whole academic year for condensed matter physics on Wednesday at 4.
Okay, let us finish this. We should be done by 4. We will find another place. So this is bad. You see, we have a lot of unclaimed glidings for a long period of time. This should not happen. This is clearly a mistake somewhere. You should find it and fix it. The factory can produce a daily email that provides information about this kind of information. If you're interested, ask the factory admins, they will send it to you. Or just write to your own. As you see, you can find all this information from historical scripts, from class ads. There's a lot of possible ways, but the factory can provide this kind of information for you right now. There is nothing in the front end that allows you automatically to do it, although we should provide that eventually. Now, how do you find the root cause when we see something like that? You should definitely start by analyzing the latest snapshots. And you start with condor status, condor Q, gliding status, condor Q, the front-end web. This will, and then you shall narrow down the research to as few sites as possible. And then start comparing the job requirements with gliding start expressions and figure out eventually what is not matching. And this can be daunting because they are not the real good tools to do it. In theory, Condor provides Condor Q minus analyze. It's there, it actually works. Unfortunately, it doesn't provide you any help. Because Condor Q minus analyze really looks at the job requirements. So if the job requirements are empty and all the start expressions are in the start D, we will end by 4. This really doesn't know what to do. So you are pretty much on your own by manually doing the job of Condor negotiator, trying to figure out which part of the requirements didn't match. After a while you get a hand, it's not too bad, but yeah, there's nothing automatic right now. The other side of the problem are unmatched jobs. So you have jobs that will never, for which glidings will never be asked for because there are not factories that actually match those jobs. So glidings will never start. So jobs will stay in the queue forever. And
excuse me, I'm sorry that you're going to have to move by 4.
Yeah, we will.
Oh, okay, I have a room for you, a big room with everything.
Okay, we need to finish this and then we'll move.
Right, okay, we need to finish by 4?
Yeah, we will.
All right.
Yeah.
Is somebody here that works?
Yeah, Jeff, can you go with her?
Okay. 26.
So the two likely reasons are you either have a wrong matchmaking policy for whatever reason, that is not considering something or excluding some kind of jobs, or you think you can go to simple size, but the fact of it is it really is not supporting if it's configured. So let's see. How do you notice that you have some problems? Well, you have a nice unmatched factory in the monitoring, or look in the logs and see what they are. This should be close to 0, unless you know that somebody is playing around and has a bunch of jobs that will never start for whatever reason. And again, when you find that you have a problem, how you find out the root cause, it's pretty much the same on the queue, and then minus on the status minus any minus constraint, glide resource minus L or whatever. And then start comparing. Again, there are no automated tools. You will need to do Python Python expression evaluation in your head, or write your script. But yeah, they're not automated tools. But this is how you get there. I know it would be nice to have an automated tool, and we should provide one, but right now there's not. But at least you know how to get there, even if it's not obvious. Yeah. Another problem are started jobs, because any the start is always a CPU. And how do you notice it? Easy. On the queue minus format, num job starts. If this is more than 1, you have the started jobs. Why it happens? Well, glides disappear for whatever reason. We discussed this already. You have hit the end of lifetime of we said glides are limited lifetime. You have preemption policies turned on. By default, we don't, but if you do, expect restarted jobs, because that's what preemption is all about. And you may have your submit node that is overloaded, because Condor really doesn't like to be overloaded. And if it starts swapping, it will essentially hit the wall and die. Then all the job will stop running, you will start running again, hit the wall, die again. You get this nice saw. When you see a saw in your, that's likely it. You don't want to get it. So why glide disappear? 3 main reasons. Remote node just died, which is rare. Site preemption policies. Just some sites are just preemption happy. And not much you can do about it apart from avoiding them, if you really care about them. Or just they just waste their own resources. As long as you're not built for them, it's fine. Or the glide is killed because it exceeded slot limits. And the most likely slot limit, apart from time, is memory. In glide, the factory actually advertised the glideinWMS MBs, which is what we think the site is imposing as a memory limit. Why can this limit be exceeded? Well, you underestimated the job resources. Your matchmaking logic is broken. Essentially, the job told you that the job needs 4 gigs, and you match it to the 2 gig site, for example. Or there are the wrong advertised limits. The factory advertised the limit is 2 gigs, and it's really 1 gig. And then Screama does, which means does factory admits. And we'll see what we can do about it. The other limit is, of course, time. And glide is usually automatically deal with it. Will go away before the deadline. Killing, preempting any jobs if needed. The limits are advertised as gliding max wall time and gliding date to die, as explained before. And again, why would ever the job stage the deadline? You may have the job itself may have underestimated the time, or have not declared it. And the front-end matchmaking logic had a problem. It knew that the job needed 24 hours, and the gliding had only 10 minutes to live. Still try to put it there. It's your problem at that point. Job failures. Jobs can fail for many reasons, and you should monitor them. Code history actually advertise exit code to see what it is. Now, knowing what users run is often needed to interpret errors, and this is very VO specific. I don't have a recipe. You should know your users if you want to help them. If you figure out that it's due to worker node errors, you should create your appropriate gliding scripts so that gliding fails instead of jobs, so jobs never fail. I really stress this all the time. Write validation scripts. It's much better if a gliding fails than a job fails. The negotiation time, try to keep it below 5 minutes because it goes much below that. For whatever reason, glidings may not be matched before the period goes away. And yeah, you may reasons are CPU starvation from any other process running on the same machine. Auto-cluster explosion, all the tries to be smart about matchmaking, you can look what auto-clustering is. But if users don't cooperate, it's a mess, especially if they write their own requirements. Since we have to move, I'll just read the content manual. Make sure that the submit node is healthy, because if it gets overloaded, you will have a problem. And usually it's either due to poor planning. You know you want to use 10,000 glidings, but you have a too big machine. Bad planning. Or there are other processes, either interactive users or a VO portal that is to response country. And just a summary, you have plenty of monitoring options. Some prettier, some more powerful. Most of the time things just work, so don't be scared. The maintenance is usually quite low. So you don't need to constantly watch after your installation. But occasionally things will break. And by that time you should know how to look around and figure out what's wrong. So you definitely want to have good monitoring tools. If you don't like the tools that you have right now, either ask for better, look around for better, or write your own. Because when things do break, you will need good tools. Something that you're comfortable with and you like.